Okay, here are the trigonometric functions for sine, cosine, and tangent, which hopefully you learned a couple of years ago and have to do with a right-angled triangle. Here's this right-angled triangle, and if you have across from that right angle the opposite side, and the longest side is known as the hypotenuse, and the one next to that isn't the hypotenuse is known as the adjacent, then you can come up with some trigonometric functions, namely sine of angle theta, and sine of angle theta is the opposite compared to the hypotenuse. You also get cosine of angle theta, and cosine of angle theta is the adjacent compared to hypotenuse. And you get the tangent of angle theta, which is the opposite compared to the adjacent. Now there's shortcuts for all of these, and the shortcuts are really good to know because they also appear on your calculator. At least those signs or symbols do. Sine, cosine, and tangent. Sine, cos, and tan. And those are equal to op over hypotenuse, and adjacent over hypotenuse, and opposite over adjacent. And these can be shortened yet again another step to SOHCAHTOA. And hopefully you've heard of SOHCAHTOA, the sine opposite hypotenuse, cosine adjacent hypotenuse, and tan opposite over adjacent. But there are more ratios. So a ratio, again, is just comparing two things. So sine compares opposite and hypotenuse. There are actually three other ratios known as the reciprocal ratios that we need to also learn about. So here's what they are. The first new one is the reciprocal to sine. So if sine is opposite over hypotenuse, there's a new ratio called cosecant. And cosecant of an angle is the hypotenuse over the opposite. That's what a reciprocal is when you flip a fraction. The numerator becomes the denominator becomes the numerator. And the shortcut is CSC, which is cosecant theta is equal to, as I had before, hypotenuse over the opposite. And we can do the same with cosine and tangent. The reciprocal for cosine is known as secant, and shortened to SEC, secant. And the reciprocal for tangent is known as cotangent, and is shortened to cotan. And they, of course, are reciprocals, so this is hypotenuse over adjacent for secant, and adjacent over opposite for cotangent. So we now have the three basic trig ratios to know, as well as three new reciprocal ratios. Let's take a look at how all of these react on a circle. So let's take a look at a circle, not necessarily a unit circle. And our circle needs some sort of a radius, I'll call it r, and a point on the edge of the circle would have some coordinates. It would have coordinates x, y, and let's call it point P. So you'd go over x in this direction and y in this direction, and notice that would work in any of the quadrants. The coordinate would still be x, P. And now when you start to think about your angle that's formed with this reference angle triangle, you start to get some of these ratios. Well, if you take sine, it's opposite over the hypotenuse, so y over r. That would mean cosecant, which is the reciprocal, is r over y. If you looked at cosine, you would have x, the adjacent, over the radius, and so the opposite reciprocal function would be r over x, secant, and tangent, which is the opposite over adjacent, would be y over x. That's the slope, by the way, y compared to x. And cotangent is the reciprocal, which is x compared to y. And then one other really neat thing is, because this is a right-angled triangle in here with x and y and r, Pythagoras actually is true. So x squared plus y squared is r squared. And if you know two of them, you can figure out the third one just by using Pythagoras. But if we rearrange this, just looking at the r squared for a second and then taking the square root, the r is always just the positive square root of x squared plus y squared, and that's because the radius is always positive. It's always a length. So one little neat thing is that fact that r is always positive. And the fact that r is always positive is going to be key for our next steps, and it isn't true for x and y. If we're in quadrant 2 and you had a point P, well, the x value would be negative and the y value would still be positive. So the x's and the y's are going to change signs, but the r value will always be positive. So here's our next section and how we start to tie some of that in. Okay, let's first take a look at those angles in the first quadrant. So if we have that, then the x is positive, the y is positive, that r value is positive to get to some point x, y in that first quadrant. And then all of our ratios have both y, r in the terms of sine and ry as positive. Cosine is a positive and r is also positive, so x's and r's are positive and y's and x's are all positive. So you'll notice that every single one of these 6 ratios is positive. So if I just make a little note that all 6 ratios are positive in this first quadrant, that's something that's great to remember. Let's just put that aside for a second and see what happens in the second quadrant. Well, now my x values are going to be negative. So basically you have a negative x value, but your y and your r, let's put y in the right spot, your y and your r are both positive. So if you look at these 6 trig ratios again, we can now see that the trig ratios have different signs. So because the x values are negative, a negative divided by a positive, and a positive divided by a negative, and same here with a positive divided by a negative and a negative divided by a positive, those ones are negative, while sine, because it's a y and an r value, which are both positive, is positive. So in this quadrant here, only sine and the reciprocal of sine. And the reciprocals will always be positive as well if the original one is positive. Only sine is positive. If we do this in quadrant 3, you'll notice that the y value becomes negative and the x value becomes negative. So let's see what happens there. Okay, with both the x and the y values negative, tan and cotan become positive, and because the r value is still positive, positive divided by a negative and a negative divided by a positive make the other 4 ratios all negative. So in this one, tan and of course the reciprocal cotan are positive. So we've got all, we've got sine, we've got tan, we'd be missing one, which would be that cosine should be positive. So let's see if that's actually true. Here's the picture. You'll notice that y is now negative. So when I write my ratios, a negative divided by a positive is a negative, and a negative divided by a positive is a negative, and the cosine graphs are positive and positive, and so we were right, the last zone that in quadrant 4 we have cosine and its reciprocal secant being positive. So in summary, there are always 2 quadrants in which the ratios are positive. All of the ratios are positive in the first quadrant, and then sine and its reciprocal are positive in the second quadrant. Tangent and its reciprocal, cotangent, is positive in the third quadrant, and cosine and secant are positive in the last quadrant. And the easiest way to remember this is with a little acronym, ASTC. You could say all suckers take calculus, or all students take chemistry. There's a few different little acronyms I've heard for this. But if you can remember ASTC, then you'll know which two quadrants your answers are positive in, and you'll also know which two quadrants your answers are negative in. So let's take a look at how we can actually use this information to solve some questions.